So this video is going to be about probability. So starting with experimental probability. This is essentially where you have some kind of experiment and it's performed a number of times. The amount of times is called the amount of trials. The different results of this experiment are called the outcomes, and the frequency is essentially how many times each outcome has been outcome happened, and the relative frequency is how many times an outcome happened out of how many trials there were. So for example, here we have someone bottle flipping, and there were 100 trials. The two different outcomes was that it landed on its bottom or it landed on its side. The frequency was it landed on the bottom 7 times, it landed on the side 93 times. So the relatively frequency of it landing on the bottom is 7 divided by 100, meaning that the relative frequency is 0.07, and the relative frequency of it landing on the side is 93 divided by 100, which is 0.93 out of 100, or 0.93% of the time. Next, there's representing combined events, and the terms you need to know is that you can represent it with a list, a 2D grid, or a tree diagram, and also Venn diagrams, but that's not important right here. So here, for example, we have someone flipping a coin. Heads is represented by H, tails is T, and here we have a sample space, which is essentially all the different results we can get. Now for theoretical probability. This is represented by P, which is P for some event happening, and that equals to the opportunities for that event to happen and the total number of opportunities of events, or the total number of events that can happen. Lastly, we have the tree diagram, and that's essentially a tree showing all the possible outcomes. So here we start, the first outcome is B, and then it can either end up with S or B, and here we have another outcome which is S, and after that you can either get the outcome S or B once again. The way you would represent this in a 2D grid is here you essentially have one axis for each bottle throw. So here we have bottle 1 side and bottom, and bottle 2 side and bottom, and where they intersect is one of the possible outcomes. So again, using an example with bottle flipping, this bottle has been flipped 2 times. The possible results are bottom, which we're going to shorten with B, and side, which is shortened by S. P with at least 2 times tails is 4, because 4 out of 8 of these has at least 2 T's, meaning that there's a 4 out of 8 chance, or a half chance of getting tails, or at least 2 tails. So for example, P for getting 3 tails is 1 out of 8, because getting tails 3 times, there's only 1 out of 8 different results, so it's 1 divided by 8. And P for 3 tails, knowing that there's at least that there has to be at least 2 tails, which means that you know that once you've hit 3 heads, 2 heads, or anything in this fashion, it means you cannot get the 3 tails, meaning that you can essentially exclude these and then only use the results with 2 tails. Next we have compound events, and compound events are essentially events which are dependent and independent of each other. So, and this is represented by P of A and B equals to P of A times P of B. So here's an example. It's getting a specific card in a card game. So this is best represented by a 2D grid. So here we have all the different suits: spades, clover, hearts, and diamond, and all the aces, or all the numbers, quote unquote. So ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And essentially the dependent result is the one that depends on 2 other results happening, and the independent ones are the single results or outcomes. So the chance of getting an ace is 1 out of 13 because there's 1 here and there's 13 other numbers which it can be. P of a card being spades is 1 out of 4 because there's only one spades and there's 4 different suits. But getting ace of spades, you essentially take both of these into account, so we find out where this line intersects spades. It intersects here. There's only one intersection of ace and spades, meaning that you can also multiply these two, so you get P of ace and P of spades, which is a quarter times 1 out of 13, which equals to 1 out of 52, meaning that getting specifically ace of spades, there's a 1 in 52 chance of that happening. Next, there's sampling with and without replacement. So sampling is essentially you have a bag, for example, of something in it. It could be, in this case, marbles. So the marbles are your sample. And then sampling is essentially you take out one of the marbles or an object if it's arbitrary, and then you observe it, see for example what color it is or what size it is, and then if it's with replacement you put it back in, and if it's without replacement you keep it out. So for example here we have a bag with marbles. There are 2 red marbles and 5 blue, so when one is taken it is put back in. So using this tree diagram we can show the different possible outcomes. So for 2 blue marbles being picked out, the chance is 5/7 times 5/7, which equals to 25 out of 49 of the times. And as you can see here are the other results. So if you wanted to take the probability of a specific combination, you essentially just take the probability of each one and multiply them by each other here. So for example, if you wanted to find P of getting a red one first and then a blue one second, you take the 2 out of 7 because there's 2 marbles and there's 2 red marbles and 7 in total. So 2 divided by 7 times 5 divided by 7 equals 10 divided by 49. And one important thing is that if you have all of these outcomes, it's important that it is equal to 1 in total. If it's not equal to 1 in total, then something has been done wrong. So here's an example of sampling without replacement. So here you have a bag of sweets. If you take something out, you're going to eat it, so you won't put it back in. So essentially what happens here is in the start you have a 4 out of 7 chance of getting a licorice, and here you have a 3 out of 7 chance of getting a chocolate. But once you take one licorice out, that means there's 3 licorice and 3 chocolates, and that means that there's only 6 in total, meaning that getting another licorice, there's a 3 in 6 chance rather than a 4 in 6 chance or something like that of getting a second licorice. And as you can see here, if you get a chocolate first, then the chance of getting a licorice is going to be higher, but the chance of getting a second chocolate is going to be lower. And here again you can see the different possible results. So as you can see, it's most likely that you will get a licorice at some point, and it's least likely that you will get 2 chocolates in a row, as you can see here, because it's only a 6 in 42 chance, while the others are 12 in 42. Next we got mutually exclusive or disjoint probability, and that essentially means if 2 outcomes are mutually exclusive or not non-mutually exclusive. Mutually exclusive and the word disjoint are interchangeable. They mean essentially the same thing. So how do you determine if 2 outcomes are mutually exclusive or non-mutually exclusive? Well, you can find that out by taking P of A or B equals to P of A plus P of B. So for example, P of ace or 7 is 8 out of 52 because there's 8 different suits of each of those cards, and there's 52 cards in total. And P of ace plus P of 7 is equal to 4 out of 52 because there's 4 different opportunities to get a 7 and 4 out of 52 for ace because there's 4 different suits of aces, which equals to, that's not 4, that should be 8 out of 52. Next, there's how to determine if something is non-mutually exclusive. Well, that's pretty simple. You take P of A or B, and that has to be equal to P of A plus P of B minus P of A and B. So in this example, again, we're gonna take P of the card you draw being a heart or a 7, and if we try and use the formula we learned before, we get that the chances of it being a heart or a 7 is 16 out of 52 because hearts account for 13 of the cards, while 7s only account for 4 of them. So, and they overlap once, so that you subtract 1 from them added together, so that equals to 13 plus 4 minus 1. And as you can see here, P of hearts plus P of 7 equals to 13 plus 4, and that equals to 17 out of 52, which is not the same as 16 out of 52. So to determine if outcomes are non-mutually exclusive, we use this formula because, as you can see here, P of heart or 7 is 16 out of 52, as we learned earlier, and P of hearts plus P of 7 is equal to 17 out of 52, but if you subtract P of hearts and 7, you'll see there's only one occurrence of this, and this is here where they overlap, meaning that only happens once out of 52, meaning that this together is equal to 16 out of 52, meaning that this equation works. So lastly, we have Venn diagrams and conditional probability. Well, first we start with Venn diagrams, and essentially Venn diagrams can be used to describe the amount of outcomes of an experiment or something like that. So for example here we have again drawing cards out of a deck of cards. A is our chance of drawing a king and B is our chance of drawing a 4. Well, you'll realize that this isn't exactly true because this here in the middle requires for the card to be drawn to be both at the same time, which isn't exactly possible because a card can only be a king or a 4. So the better way to describe that situation is with this here. So here you have circle A, which is the chance of drawing a king, and circle B, which is the chance of drawing a 4. And then the way you would describe the chance of drawing either a king or a 4 is by using the union of A and B, which is shown here. So you have the P of A union B, and that is equal to P of A plus P of B, which in this case would be the 8 out of 52. This also means that since these two cards cannot be the same card, it means that the intersect between these two circles has to be 0 because they cannot be the same. And then we have conditional probability, and that is essentially an event which can only happen if another event happens. So for example, that A can only happen if B also happened. So this could be the chance of finding a person who has gone to school, that is B, and the chance of finding a person who graduated, that might be A. And the way the notation of this is shown here, so A and then this line B means that A can only happen given B has also happened.